Okay, you've already seen that introductory video about the TIP-120 bipolar junction transistor. If you remember the video you watched a long time ago about the different types of transistors, the kind that's used most often is the MOSFET. Bipolar junction transistors are not used nearly as often. But this model of a bipolar junction transistor does allow a pretty big current, which is one of the advantages that MOSFETs have over bipolar junction transistors. In the video that you watched, it said that the current so you're using the Arduino to switch a circuit that goes through the collector and the emitter. And in the video, it said that the voltage between the collector and the emitter can be as high as 60 volts, and the current can be as high as 5 amps. But then it also said if you do that, it's going to heat up drastically, and you're going to have to take a lot of precautions about heating and stuff. And so maybe a more practical set of limits for this is a voltage of 12 volts and a current of about 1 amp. And if you stay under or around those, you shouldn't have any problem with overheating. So I'm going to always draw this way. I'm going to call this the front. There is a silver metal piece at the top, and then a part that sort of protrudes in the front that's black. If you turn this around to the other side, it's silver all the way down, so that's how I'm differentiating between the two sides. And you have the 3 prongs here that are perfectly separated. The distance is perfect so that you can plug them right into different rows of the breadboard. So that's really useful. This one is called the base. The one in the middle is called the collector. And then the last one is called the emitter. And the emitter is always going to be connected to the ground. And the way this works is when a small current passes from the base to the emitter, from the base to the emitter, it allows, I'm going to say in parentheses large, it doesn't have to be large, but this is really the usefulness of it to us. It allows a large current to pass from the collector to the emitter. The reason that this is important to us is because we can program the Arduino pins to provide small currents, and we can have it follow any kind of calculations we want. We have all this ability to control current between the base and from the pins of the Arduino to the ground of the Arduino. But the Arduino we can't use to produce big currents. And so what we'd like to be able to do is use the small current that we can generate from the Arduino pins as a switch to determine whether a larger current flows in kind of a different circuit. So we'll use Arduino programmable pins to control the current that goes from the base through the transistor through the emitter and this will determine whether a large circuit whether current can flow through a large circuit. I'm going to do two different types of like two examples of how to do this, one just for a general device, and then I'm going to do one also for a motor, because a motor is very often the high-powered device that we're going to want to use, and motors have magnetic effects that we have to account for with one little tweak. One thing I want to say before I get into these examples is in a schematic, this type of bipolar junction transistor looks like this. These schematics look different for every kind of transistor, but so this is what the symbol looks like, and this wire is the base, this wire is the collector, and the last one is the emitter, and like I said, the emitter is always going to be connected to the ground. So this is the emitter, and it's always going to be connected to the ground. And when I say ground, there is a pin on the Arduino that says ground. There's actually two of them, and so the emitter will always be plugged into that pin that says ground. Okay, so for the first example, we're just going to talk about a general device where we're assuming this isn't a motor. Let's say that I'm just picking a random numbered pin, but let's say pin 9 on the Arduino is programmed to alternate between a voltage of plus 5 volts and 0 volts each second. So let's say, just to visualize what's happening, this isn't going to come into what I'm going to ask you to do, but it'll be 5 volts for a second, then 0 volts for a second, then 5 volts for a second, 0 volts for a second. And remember that voltage is always the difference in electric potential between two different points. So it's not quite enough really to say that pin 9 has a voltage of plus 5 or 0. You have to say what that is relative to. But the answer to that is just always going to be the ground on the board. So in parentheses, I'll just say relative to the ground. And so anytime I talk about a point having a certain voltage, that doesn't technically make sense, but it just means that compared to the ground, the voltage is 5 volts higher at the location I'm talking about than it is at the ground. And so what I'm going to do is I'm going to draw a bunch of elements, and then the exercise is to connect wires so that so that this programmable pin is determining when the device is on and off. So we're going to connect wires so that pin 9 controls the device. When I say controls, it means it's switching on and off the device, even though the current powering the device isn't coming from pin 9. Okay, so what do we need here? We need the TIP-120. We need a resistor. A 1,000 ohm resistor is what I'm going to put on here. That's at the low end of what's acceptable. It might be a good idea to do a little higher, maybe 2,000 ohms or something, 3,000 ohms, somewhere in the range between 1,000 and 3,000. And then here is the Arduino board. There's the microcontroller, and all we care about, there's pins all the way up both sides, but we just care about the ground over here and the output pin 9 over there. And then we will have the battery, and let's say that this device runs off of a 12-volt battery, so let's make this the positive and this the negative, and the voltage is 12 volts. And then the device is here, and let's say that the positive terminal is there, the negative terminal is there. Okay, so how am I going to connect all of these elements so that the 12-volt battery powers the device only when the pin 9 is at a voltage of 5? Well, we're always going to be going from the output pin that we're using, output pin 9 in this case, through the resistor that I said should be somewhere between 1,000 and 3,000, and then finally into the base. So what that's saying is we want to have a small current coming from pin 9 that's going from from pin 9 through the resistor to the base, and then that inside the transistor, that current can go through the transistor and through the emitter. Okay. And so I'll start there by saying, okay, we're going to go from pin 9 through the resistor. And I didn't draw this on a breadboard on the assignment. I'm going to ask you to do very similar things to this. I did put a breadboard on that. You can just connect the wires if you want, or you can use the breadboard slots. I do have it so that the transistor and the resistor are on the breadboard, so you do have to use it for that. But other than that, I don't really care how you connect the wires. And then the other end of the resistor goes to the base. Okay, and what about the emitter? That always goes to ground, and so I'm going to go, I chose black for ground, and I'm going to go there, and I'm also going to say I want the ground of my battery to be at the same electric potential as the ground of the board. And so this is a pretty common thing we're going to do. We're just going to say that those two have to be at the same electric potential. Okay, so the two grounds are sort of connected. You can think of it that way. And now what we have is, so think about during the second where this pin 9 is at 0 volts. There's no current flowing through here. And so this transistor is switched off. And then when the pin 9 goes to plus 5 volts, now current flows through the red, through the resistor, through the base, out the emitter, and to the ground. And that has the effect of switching the transistor on. Okay, so what happens when the transistor is switched on? Well, from the positive terminal of the battery, we go through the positive terminal of the device. And then we connect the negative terminal of the device to the collector. And now this current, when the switch is on, can flow through the transistor, out the emitter, and to the ground. And so what this does is when the pin 9 is at 5 volts, current flows through the base and the emitter. That switches the transistor on, and that allows current to flow through the device, through the collector, out the emitter. Okay, so that's the basic idea. For part B, let me draw a schematic of what this looks like. And it doesn't matter where, like in space, whether things are on the left or right. It just matters what's connected to what. So I'm going to draw my pin 9 over here, just as like an empty circle. And it's going to go to my 1,000 ohm resistor, or 1 kilo ohm. And from the resistor, it goes to the base. And so there's the transistor. And I'll just continue this and draw the ground. That's a symbol for the ground. And then from the collector up here, I'll draw the negative terminal of the device and then the positive terminal of the device. I'll step through all this after I finish. Then to the positive terminal of the battery, and then the negative terminal of the battery will connect to the ground. And this is 12 volts. Okay, so what happens is when this transistor is switched on, because pin 9, you call it going high, when the voltage goes high for pin 9, that allows current to flow through the base and out the emitter. That switches the transistor on. And now that the transistor is on, current can flow from the collector to the emitter. And so we have this separate circuit that goes through the collector and the emitter. So we go from the positive terminal of the battery, through the positive terminal of the device, out the negative, flows through the circuit, through the transistor that's now on, and then flows through completes this circuit. Okay? There's one thing that you have to do differently when the device is a motor. And that is, you need to add a diode to protect the transistor and the Arduino pin from a voltage surge, and that voltage surge comes from magnetic effects. When that motor goes off, there's a rapid change in magnetism, and that rapid change in magnetism produces a voltage. Okay. And they did show you one way to do it, one way to wire it in the introduction video. I think this is a more kind of intuitive way to do it, but either one of these works. But essentially all you need to do is, if this is the motor, and this is the positive, where the current would enter the motor, and this is the negative where the current would exit the motor. All you need to do is put a diode in here that allows current to flow in the direction from the negative to the positive. The diode in your kits is a black. It looks sort of like a resistor, but it's black with a white band closer to one end. And what a diode does is it allows current to flow in one direction, but it doesn't allow current to flow in the other direction. And so when things are going the way you expect them to go, and current is flowing into the positive terminal of the motor and out of the negative terminal of the motor, it's like this diode isn't even here, because no current is allowed to flow from left to right. That's what the white band on the left side tells you. But when you switch the motor off and there's this abrupt change in magnetism, it develops just a rapid, short duration voltage that actually is higher on the negative side and lower on the positive side. And so to keep that from damaging anything, we have this diode here that allows that voltage to equalize by just passing between, from the right terminal to the left. And that's all you have to do. And you don't really have to know anything about why it works. You just have to remember to do that, or things can be damaged. So a diode allows current to flow only one way. So in your kits, like I said, I just drew this, but, well, let me draw it the other way. Just, so, okay. This diode allows current to flow that direction, and a schematic of a diode has an arrow showing that current can go this way, and a line in front of the arrow showing that current is blocked if it tries to go back the other way. So this is the direction of current flow. Okay, so the one on the left here is just kind of a cartoon of what it really looks like. The one on the right is what we'll use in schematics. And so I'm going to redo the last example. The only difference is the device this time is going to be a motor. So this is the same as last time. But the device is a motor. And I'm going to basically draw things in the same locations. So here's the TIP-120 with the base, collector, emitter. And here is the resistor that I'm still going to say is 1,000, and maybe would be better off being 2,000. And then here's the board, the Arduino, and all we care about is the ground pin and our programmed pin 9. And that pin could be any number. It just has to do with what pin you program into your program. And we'll get into programming in class on Tuesday. And then I'll put the battery here. Where did I put it on the last one? I'm going to move it over a little. And this is the positive, negative. I'll say this is 12 volts again. And then I'm going to put the motor here. With the positive terminal here and the negative there. And then I'll draw the diode here. We know we're going to just want to connect this going from the negative to the positive of the battery. So I'm going to draw it in a way that allows me to do that without crossing the wires and things like that. And that's everything. So just like before, I'm going to start out by thinking, well, I didn't start this way last time actually, but one thing that we pretty much always know is that the emitter is going to connect to the ground. So I'm just going to thread this wire through here to the ground of the Arduino. And we also know that the ground of the Arduino we want to be the same as the ground of the battery. Now for the small current to flow through the base and the emitter, I'm going to go from the pin 9 through the resistor and into the base. So now when that pin 9 is programmed to be at plus 5 volts, current goes through the red wire, through the resistor, through the base, into the transistor, and out of the emitter and back to ground. And well, we know that just the little trick that prevents the components from being damaged, we're going to connect the diode to the motor this way. And then the positive terminal of the battery is going to go to the positive of the motor. And then the negative terminal of the motor is going to go to the collector. And there you go. So when your voltage is high on the pin 9, it allows current to flow through the transistor from the collector to the emitter, and that says that this positive current goes through the motor, through the collector, out the emitter, and to the ground. And that'll power the motor. And this diode is just here to protect the sensitive components from these magnetic effects that happen when you abruptly change the magnetic field. And then the last thing that we want to do, so this is our part A. is we want to draw a schematic of this. And it's going to look very much like the last schematic. It's just going to have that diode in there. So this is our pin 9. And it goes through the resistor. And into the base of the transistor. And the emitter goes to the ground. Now the collector, a current is going to flow. I'm sort of drawing this backwards of the direction of current flow. But this is the motor. I'll just label it M. This would be the negative terminal, and over here would be the positive terminal. And that is going to come from the positive of the battery. This is a 12-volt battery. And then the ground of the battery connects to the ground of the Arduino. So if you look at this now, what we have is a positive, the current flows from the positive terminal of the battery through the positive of the motor, through the negative of the motor, and when the transistor is switched on, the current flows through the collector and out the emitter. The one thing we don't have yet is the diode, and that needs to allow current to flow only from the negative terminal of the motor to the positive. And so I will put that here. Current can flow this way, but not the other way. And that's a schematic for a circuit where that pin 9 controls whether a motor is on or off.